So, what are you going to get? Well, very quick XNA overview. How many folk here have used XNA already? Okay, how many XNA, I'm going to use the word virgin, but that's not a good one. How many people that haven't used XNA before? One or two? Okay, this is like a really quick top-level overview of XNA, followed by a drill down into how my sample game works. So as far as I'm concerned, all the context is in making some kind of destruction golf type thing. And I'll do the same format for the lecture on Friday, which will cover the same thing, but in the context of how to use XNA with the Farseer physics engine. So some of the things I'm doing today will lead a bit into that. So yeah, making a yeah. Okay, that's a very good question, and I better make the. I am expecting you to use Farseer version 2 and XNA 3.1 because it's easier. Farseer 3 is really good, but I can't get my head around it, and so I'm expecting you to use XNA 3.1. If you want to use 4, you can, but 3.1 is easier to work with and has a path to the hardware we haven't got with 4 just yet. Is everyone okay with that?
So if we're using 4 and 3.1, is that going to be an issue?
You're using 4 rather than 3.1.
XNA 4, Farseer 3.1. Well,
If you've made it work, no. If you've made it work, come to my talk on Friday and give it. If you haven't, then then I'm going to do a very, very simple physics model with Farseer with a few objects, which is easy to understand, which people can steal. All the code I'm about to show you will be up there too for you to steal and play with as well. So we're going to look at how to make things move around, how to make projectiles, how to pan the screen, and a bit about the game state. And so these are all stuff you need to know. As far as we're concerned, the ball, the thing that, if I draw on the screen it won't show up on the presentation, but the ball is basically a texture which is a bitmap pattern and a rectangle. In my game it's a rather boring yellow blob, but you can make it whatever you like, and the rectangle is there to define whereabouts on the screen the ball is drawn. If you haven't done XNA before, then that's how XNA works. So we have a design which you can create using Paint Shop or whatever, and we have a position which is where the ball is on the screen. The velocity is the change in position each time the ball is updated. So the ball will move across the screen following a trajectory. Okay, each time the clock goes tick and we update the game, we'll move the position of the ball by the amount given by its velocity, and we'll also change the velocity by the acceleration, because the ball's going to have to go up and then come down again. So we have to have a way of putting a gravitational pull on it. Okay, that's how it works. The model I've got is really simple, and so as far as physics, yep.
The Farseer physics engine deal with the acceleration.
Yep.
And gravity and the rest of it.
This is pre-Farseer. If you're scared of Farseer, and who isn't, and you just want to make a game that works in the quickest and dirtiest way, this will get you going. Okay, so this is pre-Farseer, but Farseer has the same ideas, but it does them for you. So velocity, how much it changes each time. Acceleration, how much the velocity changes. Okay, this is standard stuff, and that's about all the physics you need to know. If you look inside my game, which we will in a minute, I've got a texture which holds the ball design, a rectangle which holds the position of the ball on the screen, a floating point variable for each of the X and Y positions of the ball, 2 floats for the speed and the maximum speed and the acceleration. Now I've separated out X and Y because I find it easier to explain this way. If you want to go ahead and use a vector to do this, then that's absolutely fine, because basically each of these things is a vector. But if you're not sure what a vector is and don't want to go down that route, then not a problem, just do it this way and it'll work a treat. So what to draw, where to draw it, and then the physics variables, okay? And that's how it works. So look at the code. Well, no. Look at the update method first. This is the code that runs when we update the position of the ball. Okay? So the ball X and the ball Y are where it is on the screen, and all we do is we add the X speed and the Y speed to them, so the ball will now move across. If that's all we did, the ball would just travel in a straight line in one direction. Okay? We want the ball to go like that. So what we do is we change the ball X speed by an acceleration value, and do the same with the y speed. This value here will be negative. Well, the y value will be pulling the ball down the screen, because that's what gravity does. I mean, the thing that quite impresses me is that actually just using this, you can get quite a realistic looking ball movement. This code lives in the update method, and that's called 60 times a second by XNA to update everything on the screen. So is everyone okay so far? This gets called, we move the ball, we update the speed. And the idea is to push the ball down the screen. If we put this to a non-zero value, that's what you do to get wind. If the ball's going into a headwind, then the acceleration will push it back. If the ball's being blown along, that will push it forward as it goes. So if you want to have a wind variable in your game to control the flight of the ball, then do that. For my game, that value is 0. So my balls are flying in a perfect vacuum, really. They just go straight up and straight down. The thing about games and physics is you do the simplest thing that looks okay and then stop. So I've not got any spin on the ball, I've not got anything interesting happening, because as we'll see in a minute or two, you can get reasonable looking gameplay just by putting in the simple variables. Okay, so this gets called at 60 Hertz, so that means that the ball gets updated 60 Hertz. Okay, the position, right, well, I've got my X and my Y values, and all I have to do is make them into integers, because the rectangle that determines where they're drawn has got X and Y properties which are in. So I basically add 0.5 to round it up, then I truncate it to integer and add 0.5 to Y, same thing. So this is how I actually move the draw position. In XNA, when you come to draw something, next slide up I think, you tell the sprite batch where to draw by giving it a rectangle which says it's positioned here and it's of this particular size. Okay? I'm doing floating point calculations on these values because otherwise I can't get very smooth movement. I need to have values less than 1 to make it work. And then drawing it, easy peasy lemons. We just take the texture and the rectangle and the draw color and we put it up on the screen. And that just draws the ball. All the other items, the background and the little target are all drawn the same way. And as far as we're concerned, XNA just does this for us. The thing appears. Interesting diversions, you can change the color of the draw. I can draw in different colors from white, so I can make the ball get hot or cool down by changing the draw color from white to red to blue to green to yellow. One of the ways you could make your building show damage is by changing the draw color to make it darker and blacker, make it look like smoke damage. That kind of thing is all possible. And so what I'll do, I think, well, where are we? Yeah. Finally, I'll show the launching and I'll show you the code. So this is all I do to fire my ball in the air. When they press the A button, oh, surely not, I forgot my controller. Oh, anyone got an Xbox Y controller? Oh, thank you. Thank you. You may never see it again. Round of applause. Thank you. That's good. Yes. Keep your hands warm. Hey, this is a bit worn. Not that I'm complaining. So plug that in and make sure it's working. So when we press A, what happens is that he presses A, so button state dot pressed becomes the value for A. Take the thumbstick left X position, multiply it by the maximum speed, and that's the speed of the ball. Okay? And then we do the same with Y, but the Y coordinate in an XNA game goes down from the top. 0, 0 is here, and as we go down, Y gets bigger, which is annoying. So the gamepad, the further up you press it, the bigger the number as well. So to get the speed to work right, I just make that negative. Again, don't worry, just copy the code. And what this will let you do is fire the ball in the air. And finally, once I've fired the ball, I set a flag to say we're not aiming anymore, we're shooting. And that's the ball. That's all there is to the ball. And I'll show you it going now, because I'm quite proud of this. It took me minutes to create. Destruction golf. If you take a look in the code, then if we go further up, this is the code that declares the variables right at the top. These are all, and I put plenty of comments in so you know what you're doing. And then down here in update, well, we load in our pictures, we set some display width bits and pieces, and having done that, then we can dive into making the actual game work. Go into the update method, and here's the code that does the firing the ball. If A is pressed, we set the speed up, and then we clear the thing. So if I run the game up now, you can see what I mean by this. This is wonderful clip art. If I use the right, one of the things you haven't got on this game is it doesn't show you where the ball actually is being aimed. Now you can add that, that's for you to do. So if I take this thing and push it top right and press A, it fires the ball up in the air and it scrolls and then the ball goes off into the bitmap, which is a bit sad. But I can fire it vertically and it'll go up and then come down, bang, somewhere. Or I can fire it and actually hit the thing. Oh, maybe not. Oh, that's even worse. Ah, good. I got it, okay? So what you're seeing is the physics model that I've just made for you. Nothing more, nothing less. And I can do little shots, or I can do big shots, just by moving this controller up and down. So if you're worried about the actual control working, then it turns out to be quite easy to do, because you just have to use, and what I've got is I've got a fairly massive value pushing the ball back down again. And I really should put in some limiting code to stop it falling into my bitmap, but there you go. Try it one more, go, one more, go on. Boink. And finally, got it. Not, the pixel collision detection is not perfect. In fact, it's pretty ropey, but that should give you an idea of how I've made it work. This ball here is being controlled by the code you've all seen. And if you want to make it go faster or slower, then just tweak the numbers. Is everyone okay with that? It's quite sweet, actually. I'm quite not totally unhappy with the code. So having put that in, let's go back to the slideshow. And there you go. Off we go. So the target's really easy. The target's just a texture and a position. And I'm placing the target on the screen about there. And it gets drawn with everything else. When I want to detect if the balls hit the target, I just use the intersects method. The ball rectangle provides a method called intersects, which looks at the target rectangle, and if that returns true, it means that we've got a collision. We play a sound effect called bang sound, and put the ball back on the screen somewhere. Questions? This is not particularly fantastic code, but it works. Okay, so that's the collision detection. This is getting easier all the time. Scrolling background. What I've done is I've made the background quite big. The background's about 2.5 times the width of the screen. In fact, if I can show you the code that does that, because it isn't in the lecture. If I go and have a look in load contents where you fetch all your stuff, so if I go and have a look in there, there's my background, okay? Go and fetch the wonderfully drawn green rolling hills with the blue sky, and then I make a rectangle which is the same height as the screen and 3 times the width. Okay. If I want a much wider screen, just make that say 5. And what will happen now when I run it is it'll be much harder to fire the ball off the screen. My hills are now flatter because they've been stretched. But if I now actually get my bullet and fire it up in the air, there you go. It'll not fall off the end quite. Okay. Right, monkey. Let's sort that out. This might not work actually. 15. Have very flat hills now. And if I fire it like that, pardon? It hasn't changed. Why has that not changed, Robert?
Are you firing it at the same place?
No, I thought that should work. Let's keep going. No, it's not worked. Right.
Surely you need to place the rectangle inside the in the draw method, in like how to draw it. You know what I mean?
I do. Okay, we'll have to go and look at that later. That's an exercise for you to sort out. I think I'm using the wrong form of the draw method. That's all it is. Yes, I know why it is. It's because I'm an idiot. Yes, you're quite right. If you look at the draw method down here, this is all being recorded, which makes it all the better. Hey. Go further down here. This is my draw. Yeah, I'm drawing the back texture just with at the top left-hand corner. not using a rectangle, so it's just drawing it the size it is. So if I go into Paint Shop Pro or whatever and make it really long, it'll work fine. I've got this nice panorama of Princess Key, which I might put in here and use that as the backdrop for my destruction, which will be quite interesting. But I digress, but not particularly far. So, showing you that didn't work. But it's important. There's a really nice trick you can play here to do with scrolling. I've got the back texture is bigger than the screen. You saw that. It is bigger, isn't it? Yes. Right. Good. What I do is I use a transformation matrix. Okay? This is great. XNA provides a type called matrix that lets you describe a transformation, and this is things like scaling, rotation, translation, all kinds of good stuff. Okay? Now, all I want to do is slide the entire screen in one direction to scroll it. Okay? So what I do is I make myself a transformation matrix, which I call transformation, and then I use the create translation method on the matrix class to get me a translation, which is the offset value I want to use. Now, I don't want you to worry about this too much, if indeed at all. Just steal the code because it works. Okay? But the idea is that this thing is going to produce a matrix which translates the entire screen by the amount in that variable there, x offset. And the matrix is called transformation. And then when I come to draw, I use a really long-winded form of the sprite batch begin command that says use alpha blend, sprite sort mode immediate, save state mode none, transformation. That's my matrix. And that slides the entire screen magically. So if you're worried about how you're going to get the thing to pan left and right, this just does it. And all you have to worry about is coming up with a value in x offset to drive it across. Okay, so everything in here, all the drawing is transformed, and that actually pans out rather nicely because it means that I can just pan the thing left and right by changing the value in x offset, and it all just comes out in the wash. In fact, this is my code for the ball. The ball says if the right-hand edge of the ball plus the scroll margin is bigger than the width of the screen, what's happening is the ball's going up like that, it's got within the edge of the screen, and so we're getting a bit close to falling off. And I have a margin value which is basically going to stop the ball from going beyond the edge. If we're going over the edge, make the offset, pull the screen back to make the ball stop at that edge. And this is the code you need, just steal it. Okay? Because this will work. And so what happens now is if the ball flies off the screen, doesn't matter, the offset will pan the entire viewport across to track it. And I've also got a little bit of extra which I thought was kind of fun. In aiming mode, I take the right thumbstick and I multiply the value in x by a scroll speed and apply it to offset there as well. So if I run the game up now, you can show what that does for you, because that's actually quite kind of cute as well. If I stop the program, no, leave it going, why not, what the heck. It's all here, it's all good. If I use the right thumbstick, I can pan the screen right and left, which is quite cute. I can do this, which is less impressive. So you're going to have to put some bounding on, but basically what this means is you can put the ball and the target on different parts of the landscape and then make the player pan across to find it and shoot it. Okay? So if we're in aiming mode, I've got that. When I fire the ball, it goes up over the top and comes down and then falls off the edge of the bitmap, but you can sort that out easily enough. Or you can aim for the thing and hit it. Okay? So this gives you the ability to make really long environments and then put targets in them. Is everyone okay with that? Yeah?
What happens if your environments are longer than 4096 pixels?
Nothing nice. Yeah, if you go, there is an upper limit on the width of a texture you can have, and I think it's 4096. So don't go beyond that. If you want to do that, you can start doing things with scaling to make it so you zoom, because your transformation could zoom in and out. I mean, one of the things you could make it is you could make it pan up as well. So as the ball goes up, it could go. This thing could pan up in the air and then come down again and follow it off a margin up there as well. But it doesn't do. I mean, is everyone okay with that? Is this going to be useful for making a game for you guys? Yeah. Okay. I'll take that as a maybe. Go back to the presentation. I've got two states in my game, aiming and not aiming. I'm using a bool for that. If I'm aiming a shot, I'm looking for the button A to be pressed, and I'm panning the screen backwards and forwards. If I'm firing, I'm doing the update routine, which is then giving the ball its trajectory. Okay, you might want to add other game states as well for multiplayer and that kind of stuff. But as far as you're concerned, you can add that to my code, not a problem. So, stuff you need to do, you can take this, add some more targets. You can have things that you mustn't hit, put in the odd hospital, another thing which you're not supposed to blow up, so they have to fire the shot through those. You can make the targets move backwards and forwards. You can add the backdrop. We can stop the player from panning off the screen, do a multiplayer mode, and as it says there, have fun. So that's pretty much all I wanted to cover in this particular part of the thing. Is everybody okay with what I've done? Does it make kind of sense? Right, now I'll put the PowerPoint deck and the sample code up on the resources on destructiongolf.com, and if this recording works, I'll put that up as well so you can hear me fail.
Which version of Farseer did you recommend?
Right, I'm recommending the demonstration I'm going to be doing on Friday. I'll do another lecture just like this. It might not be in this room, it might be in LTD, we're not quite sure, we've got a room booking issue. But we'll be using Farseer version 2.n on XNA version 3.1 because that's the one I can get to work. If anyone wants to do better than that, absolutely fine. You know more than me before you start. But I'm going to provide the same gaming environment, just using the Farseer physics instead for you to steal. If you make yourself some assets and get some gameplay working using my little sample program now, you can slide those across into Farseer on Friday if you want.
Farseer 3.
Pardon?
This is 3.0.
If you're using Farseer 3, talk to that man there because he knows everything about it.
We're good.
Wow. I'm using 3.1.
3.0.
Cool. Okay. If you're doing that, you're all beyond me and beyond help, quite frankly. So thank you for that. Okay.